All right, everyone. Welcome to another deep dive. Today we're going deep on advanced TypeScript concepts.
Sounds fun.
Yeah, we've got some great material to work with today.
Oh, yeah.
Yeah, excerpts from 10 advanced TypeScript concepts every developer should know.
Nice.
Yeah, so if you're looking to really level up your TypeScript game, this is the place to be. We're talking about reusable code, flexible data structures. We're even going to get into reflections and really look under the hood.
Sounds like some pretty powerful stuff.
It is. It is. So let's jump right in with generics.
Okay.
Now, I got to be honest. The first time I saw generics, I was a little intimidated.
Yeah, they can seem a bit abstract at first.
Yeah, but once it clicked for me, it was like discovering a secret weapon for clean code.
Oh, for sure. It can be a real game changer in terms of how much time and effort you can save.
Exactly. Now, remember that cookie cutter analogy from the source material?
Oh, yeah, that's a good one.
That's generics in a nutshell. You write the code once, and you can use it with any type you want.
Yeah, you can think of it like a blueprint that you can use to create different components.
Perfect. So let's say you have a function, and you want to ensure that it only works with numbers or strings.
Right? How do we enforce that level of control?
Exactly.
Well, that's where type constraints come in. Imagine you're building a form, right?
Okay.
And you need to validate different input fields. With type constraints, you can actually write a single validation function
Interesting.
that adapts based on the type of input that you're dealing with. So you don't need separate functions for numbers, strings, or dates. It's all handled dynamically.
So we're talking about more than just theoretical type safety here.
Oh, absolutely.
We're talking about preventing real-world bugs and making our code much more predictable.
Yeah, it's like having a safety net for your code.
I like that. All right, let's shift gears a bit and talk about generic interfaces.
Yeah.
You're probably already familiar with interfaces. They act as contracts for our objects, defining what properties and methods they should have. But have you ever wished you could make those interfaces a bit more, well, adaptable?
Oh, yeah, for sure.
Like a blueprint that you can tweak for different building projects.
Exactly. Let's say you're working with user data. You've got a user interface that defines all the properties. The name, the ID, the email.
Right.
But what if you need to interact with that data in different ways? Maybe fetching it from an API, storing it in a database, or even just displaying it in the UI.
Yeah, you'd end up with a ton of repetitive code, right?
Exactly. And that's where generic interfaces really shine. You can define what's called a repository interface,
Okay.
and that outlines those core actions like adding data, getting data, updating data. Then you can create specific implementations,
Got
like
it.
user repository or product repository, that tailor those actions to the specific type of data you're working with.
Okay, I see where you're going with this. It's like creating a reusable template for how to interact with different types of data.
Yeah, exactly.
Very cool. So it really is all about making those interfaces more flexible and reusable.
And that's a big part of what makes them so powerful. You can structure your code in a consistent and maintainable way, even when you're working with all these different types of data.
All right, let's build on that to talk about generic classes. I always think of classes as blueprints for objects. They define the properties and the behaviors. How do generics fit into that picture?
So think of a generic class as a blueprint with some customizable parts.
Okay.
Take the user details class, for example, that we see in the source material. It's designed to handle user information, but the exact type of user can be specified when you actually create an instance of that class. So maybe you have a basic user type and a nanny user type.
Right.
Well, with the generic class, you can use that same blueprint to manage both of them.
I like that.
Keeps your code nice and clean and consistent.
So you're ensuring that any operations performed within that class are type safe, no matter what the specific user type is.
Exactly. And that leads us to a concept that might blow your mind a little bit. Dependent types.
Oh, I'm intrigued. Lay it on me.
All right. Imagine you're building a function that needs to access a specific property of an object.
Okay. It's all
But you
gonna-
want to be absolutely sure that the property you're trying to access actually exists on that object.
Yeah, that sounds like a recipe for some runtime errors if you're not careful.
Exactly. And that's where dependent types come in. They allow you to make the type of one parameter dependent on the type of another parameter. It's like saying, hey, TypeScript, I need you to make sure that this property key actually matches a real property on this object. If it doesn't, throw an error.
So TypeScript is like our bodyguard, making sure we don't step into any dangerous territory.
That's a great way to put it.
I like that. All right, we're going to take a quick break, and we'll be right back with more on advanced TypeScript concepts. So with dependent types, we're talking about a whole new level of type safety. It's like TypeScript is reading our minds and making sure we don't make any silly mistakes.
Yeah, it really is taking it up a notch.
I like it. So let's move on to conditional types. Have you ever written code where the type of a variable could be one thing or another depending on a specific condition?
Oh yeah, all the time, especially when I'm working with like user input or data from an API.
Right, you never know what you're going to get.
Yeah, you never know what you're going to get. And without the proper type handling, that can lead to all sorts of runtime surprises.
Yeah, for sure.
Nasty ones too.
So how do conditional types help us out in these situations?
Well, they give you a way to actually express that logic.
Right.
That this could be this or this could be that logic
Right.
within your type system.
So the source material gives us that simple example of a function that could accept either a number or a Boolean.
Right.
But then it jumps into that more complex example with this has property type. Can you break that down for us a bit?
Yeah, so the has property type, it's essentially a type level check.
Okay.
That will determine whether or not a given type has a specific property.
So it's like a built-in TypeScript detective. Examining a type and telling you whether or not it has the goods. Right.
Exactly.
Okay, I like that analogy. So how's that useful in a real-world scenario?
Well, think about type guards.
Okay.
Type guards are functions that help you narrow down the type of a variable within your code. Conditional types, like has property, can be used to create really powerful type guards, ones that adapt based on the structure of the data you're working with.
So it's all about making our types more intelligent and responsive to the actual data flowing through our code.
Exactly. Now let's shift gears a bit. Let's talk about intersection types.
All right.
So remember how we were talking about generic interfaces being like adaptable blueprints?
I do, yeah.
Well, intersection types are all about combining those blueprints to create something even more powerful.
So like a Lego set where you can snap different pieces together.
Exactly, to build these more complex structures. The source uses a wellness example.
Right.
Mental, physical, productivity. Each one of those has its own type, and then they create a healthy body type that combines all three.
Yeah, so instead of treating those as like completely separate entities, you're acknowledging that they all intersect.
Right.
And they all influence one another.
Exactly.
It's a more holistic approach.
It is, and that's exactly what makes intersection types so expressive. They let you represent complex, real-world concepts more accurately within your type system.
All right, let's move on to the infer keyword.
Okay.
This one always makes me feel like some kind of code archaeologist, like I'm digging through layers of types to uncover these hidden treasures.
I like that. So the infer keyword is all about extracting subtypes from a larger type, but under specific conditions.
Okay.
It's especially useful when you're working with asynchronous code and particularly promises.
Oh, right, because with promises, you don't know the exact type of data you're going to get until that promise is resolved.
Right. So the example shows how infer can be used to figure out what that type is going to be when the promise resolves.
Gotcha.
So you can write code that adapts based on that resolved type, even if you didn't know it beforehand.
So it's like setting a trap to catch the type as it emerges from the promise.
Exactly. Now let's dive into something that can be a bit tricky, but is super important for working with inheritance in TypeScript.
All right, Timmy.
Type variance. It's about understanding the relationships between subtypes and supertypes and how they affect type compatibility.
Okay, you're going to have to explain this one to me like I'm 5.
Okay, so imagine you have a vehicle class. A car would be a subtype of vehicle because it's more specific.
Right, okay.
Covariance means that you can use a car wherever a vehicle is expected. It's like saying, if I need a vehicle, a car will do just fine.
That makes sense. A car is a type of vehicle, so it fits the bill.
Exactly. But contravariance is kind of the opposite. It means you can use a supertype where a subtype is expected. So you can put any vehicle in a garage, but you can't assume that every vehicle in a garage is a car.
Ah, so it's all about managing expectations and understanding that you might not have all of the specific features
Right.
of a subtype if you're working with a more general reference.
Precisely. So understanding type variance is key to writing flexible and type-safe code, especially when you're dealing with these inheritance hierarchies.
All right, so on to something that seems to bridge the gap between TypeScript's compile time magic and the realities of runtime. Reflections. I always think of reflections as looking in the mirror and seeing a reflection of ourselves, but how does that apply to TypeScript?
It's a good analogy because TypeScript is all about catching those errors before your code even runs.
Right.
But sometimes you need to figure out the type of something while your code is actually executing. That's where reflections come in.
So it's like TypeScript has this amazing foresight, but sometimes it needs to check its rear view mirror as well.
Exactly. So the type of instance of operators are our tools for doing this.
Okay.
Type of lets us peek at the type of a variable at runtime. So if we have a variable that could be a string or a number or an object type of, can tell us what it is at that very moment.
An instance of lets us check if an object belongs to a particular class. So if we have something that's supposed to be a user object, but we're not 100% sure, instance of can give us that confirmation.
Exactly. And while those built-in operators are helpful, they only scratch the surface. For more advanced situations, you might want to look to third-party libraries that offer more powerful reflection capabilities.
Okay, so let's wrap things up with a concept that's often hailed as a game changer for code organization and testability: dependency injection. This one has always felt a bit like magic to me.
It can seem that way, but at its core, it's about decoupling your code,
Okay.
bringing in external code, but without creating tight dependencies within your components.
So the example in the source material uses health-related services to kind of illustrate this.
Right.
In the non-dependency injection version, the health advice class is actually creating instances of those services directly within itself.
Mm-hmm.
But then in the dependency injection version, those services are provided externally.
Right, and that shift has a huge impact. It makes your components way more independent, more reusable, and much easier to test.
So instead of our components being like tangled headphones, we're creating a system where each component is neatly plugged in
Exactly.
and can be easily swapped or replaced.
And that modularity is a huge win when it comes to maintaining your code. If you need to make a change, you can focus on individual components without having to untangle a big web of dependencies.
All right, so we've talked about a lot today: generics, conditional types, intersection types, the infer keyword. We even got into type variance, reflections, and dependency injection. It's really incredible to see how these concepts work together to create this more robust and expressive type system.
It's like unlocking a whole new level of TypeScript.
It is. And you know what strikes me? What strikes me is how much these concepts really emphasize intentionality in our code. We're not just letting TypeScript infer things haphazardly. We're using these tools to clearly define our expectations and create a system where type safety is baked into the very structure of our applications.
I think that's a great observation. It's about going beyond just writing code that works, and instead writing code that's predictable, maintainable, and communicates our intent clearly to both the compiler and to other developers.
Yeah, I love that. So for all of our listeners out there who are ready to take their TypeScript skills to the next level, what's one piece of advice you'd give them?
I would say don't be afraid to experiment. Pick one of these concepts that intrigues you. Find a small project or even just a code snippet and just start playing around with it. See how it changes the way you think about structuring your code. And remember, the TypeScript community is incredibly welcoming and supportive. There are so many resources online, documentation, blog posts, open source projects. You're not alone on this journey.
Yeah, that's a great point. Sometimes the best way to learn is to just dive in and get your hands dirty, make mistakes, ask questions, and, don't be afraid to break things. Obviously in a safe development environment, of course.
Exactly. And as you become more comfortable with these more advanced concepts, you'll see how they can be combined and applied in increasingly creative ways. It's really like having a set of power tools for your code.
So I think we've given everyone plenty to think about today. We've explored a whole world of possibilities within TypeScript, from building reusable components with generics to crafting intricate type logic with conditional types.
And don't forget about dependency injection. It's a real game changer for building maintainable and testable applications.
You got it. Well, that about wraps it up for our deep dive on advanced TypeScript concepts. But remember, the journey of learning never really ends. TypeScript is constantly evolving, and there are always new frontiers to explore. So keep that curiosity burning, keep experimenting, and keep pushing the boundaries of what's possible with this amazing language.
Until next time, happy coding, everyone.
All right, so we've talked about a lot today: generics, conditional types, intersection types, the infer keyword. We even got into type variance, reflections, and dependency injection.
Phew, that's a mouthful.
It is. It's really incredible to see how these concepts all work together,
Yeah.
to create this more robust and expressive type system.
It's like unlocking a whole new level of TypeScript.
It is.
Yeah.
And you know what strikes me?
What's that?
What strikes me is how much these concepts emphasize intentionality in our code.
Oh, yeah.
We're not just letting TypeScript and infer things haphazardly. We're using these tools to clearly define our expectations and create a system where type safety is baked into the structure of our applications.
I think that's a great observation. It is about going beyond just writing code that works
Yeah.
and writing code that's predictable, maintainable, and communicates our intent clearly to both the compiler and to other developers.
Yeah, I love that. So for all of our listeners out there who are ready to take their TypeScript skills to the next level, what's one piece of advice you would give them?
I would say don't be afraid to experiment. Pick one of these concepts that intrigues you. Find a small project or even just a code snippet and just start playing around with it. See how it changes the way you think about structuring your code.
Right.
And remember, the TypeScript community is incredibly welcoming and supportive. There are tons of resources online, documentation, blog posts, open source projects. You're not alone on this journey.
That's great advice. Sometimes the best way to learn is to just dive in and get your hands dirty, make mistakes, ask questions, and don't be afraid to break things in a safe development environment, of course.
Exactly. And as you become more comfortable with these more advanced concepts, you'll see how they can be combined and applied in increasingly creative ways.
Yeah.
It's really like having a set of power tools for your code.
I like that. So I think we've given everyone plenty to think about today.
Okay.
We've explored a whole world of possibilities within TypeScript, from building reusable components with generics to crafting intricate type logic with conditional types.
And don't forget dependency injection, a real game changer for building maintainable and testable applications.
You got it. Well, that about wraps it up for our deep dive on advanced TypeScript concepts. But remember, the journey of learning never really ends. TypeScript is constantly evolving, and there are always new frontiers to explore.
That's true.
So keep that curiosity burning, keep experimenting, and keep pushing the boundaries of what's possible with this amazing language.
Until next time, happy coding, everyone.